This session has been sponsored by USDA's Natural Resources Conservation Service through our Working Lands for Wildlife Partnership in collaboration with support from the BLM and the Intermountain West Joint Venture. We are taping these presentations today, and so we'll have those videos available sometime after the conference through YouTube. I'd like to go ahead and get started with our first presenter. Dr. Brady Allred is a rangeland ecologist at the University of Montana, where he focuses on rangeland dynamics at broad scales with the goal of improving conservation and management. Help me welcome Brady this morning.
Okay, big thank you for everyone for coming out this morning. I'm excited about this session, and thank you to Jeremy. Jeremy and I organized this symposium with the goal of discussing and talking about new technologies that are available, that are out there, that can help us to improve our management and conservation of rangelands. Now, to set the stage, I wanted to start with this slide. When you Google rangeland monitoring, these are the images that come up. What you see are rangeland professionals looking down at the ground at plants. And, you know, although this portrayal isn't exactly perfect, I do think it characterizes where we have focused in this profession and discipline, where we have put our time and effort. And that is mainly in the identification of plant species and the ability to sample those plant species across the landscape. Now, I say that I'm a son of a plant taxonomist, and I knew how to identify and spell Bootalua before I knew how to ride a bike. And so I'm very familiar with these types of concepts. But because of all of our efforts and time being put into these mechanisms and efforts, we have put less time and less effort into other mechanisms, other ways, other technologies that actually might be useful. They don't replace what we've done, but they might be useful and may be able to help us answer the actual questions we have today. So when I say technology, and when I mention technology, and we're talking about technology in this session, what do I mean? I'm specifically talking about satellite technology in this case. Why satellites? It's because they can scale. They can scale in both space and time. And what do I mean by that? You can look at a small area. You can look at multiple small areas. You can look at big areas. You can look at multiple big areas, and you can do this all at the same time. Now, that's just scaling in space. What about scaling in time? Because satellites are repeated observations. They circle the globe on some predetermined frequency. You can determine when they're going to keep circling that globe, and you can keep monitoring, keep looking throughout time. And if they've been doing this for a long period of time, you can actually look at a long period of time out there. So technology, satellites' ability to scale across space and time. So what happens when you combine the on-the-ground data, that identification of plant species and plant sampling, with this technology, satellite technology? Well, you get new innovation, new ways of thinking about things and looking at things that we hadn't really noticed before, that we haven't really looked at before. You also get increased efficiency in your conservation and management efforts. Now, this combination of old and new technology is not specific to our discipline. It is rampant throughout many industries. In agriculture, you have precision ag, which is a combination of engineering and big data, which has led to precision ag. Uber, we took an Uber from the airport to the hotel. It's a combination of technology, our smartphones, our GPSs, to increase the efficiency of transportation. So multiple industries are experiencing these innovative ways to do something new and to increase efficiency. Rangeland management and rangeland conservation is no different. So I am not the first one to think of this by any means. In 1976, there was a paper published in the Journal of Range Management entitled A Remote Rangeland Analysis System, where this author, Dr. Maxwell, described the ability to monitor rangelands from space. I wasn't even born in 1976. But a lot has happened since then, right? So what exactly has happened from 76 to now, and what can we do now with these increases in technology? One of the first big advancements is we have this incredible legacy of satellite images available from the Landsat missions. For more than 30 decades, there have been sensors up on satellites taking images of the Earth every 16 days. And for a good period of that time, we've had two of those satellites, two of those sensors up in space at the same time. This is that medium to fine resolution data. We have this incredible data set that we can harness and use for management and for conservation. That's the first thing. Another thing that has happened from then until now, computational power has increased amazingly. Not just the computational power, but the storage capacity. We now have phones, we carry around phones in our pocket that are literally more powerful than the desktops we used 10 or 20 years ago. There have been increases in computational power and efficiency. Another big event that happened in 2008, the Landsat archive was made available to the public free of cost, free of charge. That was a huge thing. To put that in perspective, one of the projects that we're going to describe in this session would have cost us $758 million to do had we had to pay for those images. Of course, no one can pay that amount, and so by doing that, they've been able to release the capacity to do these studies, to do these projects, again, to improve conservation and management. The pinnacle of all this, all these changes, though, is that the technology and the computational power has finally caught up to our dreams. We have finally realized the potential of what we can do, and this has been through the advancement of cloud computing. Before this, there were not computers big enough in the world to process the data we needed to process or to store it on the same servers to collate the data with the computations in order to process it efficiently. But the first platform to kind of pioneer this was Google Earth Engine. There's a handful of other platforms out there now, but Google pioneered the way by making all these large remote sensing data sets available on their platforms and allowing users to access them very easily, very quickly, and very efficiently. What literally would take days to months to years to analyze can now be done with single lines of code and in the matter of minutes or hours. So that's what's changed from 1976 to present day that has allowed us to do all this. Because of this, and because of these large-scale cloud computing platforms, it's not just we can use these data and this computational power to do science projects, we can actually serve this data up to you, to rangeland practitioners who need this data at the field. We can put it at your fingertips and allow you to visualize it, to analyze it, to query, and to do things on the fly that wouldn't have been possible without these cloud computing platforms. And many of you have probably heard of the Rangeland Analysis Platform. It's available there at that URL. It is a platform that is used to visualize and to interactively analyze rangeland data sets that are meant to be used for conservation and management. So what it is it's an interactive web application where a user can go in, draw a polygon, visualize data, get the results back for their area of interest. They can use this in their planning, they can use this in their monitoring, they can use this to make decisions. This is open and freely available to the public. Anyone can use it. I encourage you to go to that, to check it out. I'm not going to walk through it today, but we have user guides available. We have tutorials available where you can look at it and see what it can do for you. Now, the big question is, we have all this data. We have all this computational power. So what is it exactly that we're doing? What are we going to talk about today in this session that can make our jobs easier, that can make our jobs more efficient, and that we can do a better job at managing? So the first data set that was available on the Rangeland Analysis Platform was a data set produced by Matthew Jones. We're actually not going to talk about it today. I'll highlight it briefly here. Dr. Jones was able to utilize the 30,000 or more plots available from the NRCS NRI and the BLM AIM programs. He combined those on-the-ground plots with decades of satellite imagery and other data to produce vegetation cover maps for the entire western United States, so from the Great Plains to the Pacific Coast, at a fine resolution, 30-meter resolution. Not only did he do that, he was able to do it for the whole period of the Landsat archive, starting with Landsat 4, Landsat 5, from 1985 to 2018. So what you get is a complete view of how rangelands have changed. He parsed it out by 4 functional groups, and this is continuous cover from 0 to 100%. He looked at annual forbs and grasses, perennial forbs and grasses, shrubs, bare ground, and trees. And so now, for the first time ever, we have a complete view of what the vegetation on these rangelands look like for the last 30 years. All made possible due to the data that was available and the increased computational power. After me, Colin Davashin is going to talk about all those little dots that you see there on that map. And he's going to talk about how we can streamline our efforts in collecting the NRI data, the AIM data, and how we can streamline them and make them readily accessible and usable for projects such as these, so we can increase, again, our ability to conserve and manage rangelands. After Colin, Dr. Nathaniel Robinson is going to teach us and present to us a production data set. So up there in the top left of your hand of the screen, you see the old production data sets available that were available at a 1 kilometer resolution. With the work he's done, he's been able to downscale those down to 30 meters using Landsat data. You can see that down at the bottom, to give us production data that is available every 16 days from 1984 to present. That's pounds per acre above ground biomass. Not as only is he able to do that, he's able to parse it out by functional group. So he can tell us how much production is due to those annuals, how much is due to the perennial herbaceous plants, and how much is due to the shrubs. Again, for the first time ever, we'll have a complete view of the productivity of all western rangelands across the western United States. After Nathaniel, Dr. Nicholas Sillerman's going to teach us about riparian sensitivity and the ability to map the sensitivity of riparian areas. How do they respond to water? How do they store water? And specifically, he's going to teach us how we can use these tools to prioritize which riparian areas we need to be working on, which ones we need to restore, to evaluate our project to see if we're doing a good job, and then to continually monitor them to see, are they remaining sensitive, or are they storing more water in the landscapes for plants and animals to use? Lastly, we've teamed up with the University of Nebraska-Lincoln, Dr. Twidwell and Dr. Uden from there, and they're going to teach us about screening and cross-scale transition mapping. Now, historically, we're all familiar with state and transition models. They've been around for a long, long time. Many of us have written papers about them. And historically, people have been focused on mapping the states. What state is this landscape in? Well, Dr. Twidwell and Dr. Uden kind of flipped that on its head, and they decided instead to actually map the transitions. And they said, tell us where the action is. Tell us where the landscapes are changing. And then once we know that, we can go in and figure out what the states are and what management actions we actually need to do. And so here's a sneak peek of that, where they're able to map the transitions and the risk vulnerability of areas changing from a perennial herbaceous grassland to tree woodland, and they're able to do this across time. So you see this in year 2000, and then you see it in year 2017. I'll go back and forth there to show the difference. They'll teach us and they'll discuss with us what this means and how we can use this in management and conservation to prioritize where we put our treatments. Lastly, why are we doing all of this? We've decided that we are not comfortable with the old way of doing science. We want to bridge the science to implementation gap. We want to be able to say that our science made a difference and improved the conservation and management of rangelands. The old science approach is that after the work is done, the data may or may not be there, the science may or may not be there, but it kind of disappears into oblivion. Our approach is the new co-produced approach where we focus on co-production, working with rangeland practitioners so the science and the data is readily available to practitioners in the field so they can use it to improve their methods to be more efficient. To do that, we've primarily focused on our web-based application, the Rangeland Analysis Platform. So it gives practitioners the ability to visualize and interactively analyze data that they need, all at the click of a mouse. We're not the only ones doing this. This is a paradigm shift that is happening in not just rangeland ecology and management, but in all the conservation disciplines. People have recognized the value of these technologies and what you can actually do with them, and the value of digital platforms and serving up that data right to people in their web browsers. So thank you again for coming. We're excited for all the talks. The talks I listed are just the talks that occur up until the break, and then we have a few more after the break talking about technology as well. So thank you for coming.